Welcome to today's webinar. This is our last one in our series for 2025, and we're continuing our discussion about multi-platform PropelZ. And today we're going to talk about running PropelZ on Windows for data integration purposes. I am Dustin Froyam, one of the co-founders of VirtualZ, and today I have co-founder and our CTO, Vince Ray, co-presenting with me. Hey, Vince.
Howdy, Dusty.
Hope you're doing well today.
Oh yeah, a little cold, but otherwise well.
Yeah. No snow though, right, Vince?
No snow.
That's
a lot
good.
of rain, no snow.
Okay, good. All right, this is being recorded. It'll be available for playback on our YouTube channel, or if you prefer, you can listen to it on our podcast channel, Skyward Data, and that'll be available for you as well. We're going to talk a little bit about the challenge with data access and integrating that for your Windows systems and downstream databases. Then we'll get more into the architectural and functional overview of PropelZ for Windows, some use cases, pricing, and we'll jet out of here for the year. So today's challenge, right, is to get all of your data integrated across your platforms, including mainframe, cloud, Linux, Windows. You see, we even have some integration into some of the other legacy platforms as well that you can use PropelZ with. And so how do you do that in a easy no-code fashion, not creating custom ETL processes or pipelines? And so that's one of the things that VirtualZ, and particularly PropelZ, excels at. And then, how do you get real-time or near real-time data, especially in your online window, so you're not just locked into your batch cycles for your data integration or your ETL pipelines? Can be costly and slow, especially some of these legacy platforms that are integrating. And so how do we address some of that? And how do we deal with sensitive data? Particularly, that's a really interesting one. You can listen back to a lot of our webinars on that topic, especially with the mainframe, which are kind of the key to the castle type data for your enterprise. And then how do we simplify this again through no code, not utilizing specialized talent and make this easy for any of your administrators or DBAs? And then, in some cases, how do we get that data unified into a common format? So our transformation engine that's available for this. So Vince, can you just kind of talk us through the basic architecture of PropelZ and particularly highlighting, how multi-platform PropelZ and Windows would operate here?
Yeah, no, happy to go into that. So PropelZ, at least the way I like to think of it is it's three parts to the PropelZ story. The first part is all about how do we get data into the system, the kind of data ingestion, if you will, or the input stage, as we usually call it. Yeah, depending on what platform you're on, that can take a lot of different forms. And, a mainframe customer, typically that's file oriented. You might have vSAM files, you might have tapes, you might have, all sorts of legacy data in various types of file structures that PropelZ would process. Some other cases, maybe that's not what you want to do. Maybe what you want to do is more like network access, FTP access, input over network, or, access a share of some sort. That's another possibility. And, one of the more recent things we've done is we've also added, basic database input capability. So, you might have the case where your input data exists in, let's say Microsoft SQL Server, and your goal is to get that pushed to, a completely different platform that maybe you're using for an AI application or, for some other need. So the input stage is very open-ended that way. We supply a bunch, we're happy to help you get to anything you need, but, certainly you can do that too. The input stage could be things like, output of programs that maybe you have already, or, sometimes people use reporting software to create records that can be piped into PropelZ. So really anything you might have as input is what you see at that stage. Then we move into kind of the middle part of PropelZ, which is all about transforming that data into the format that you want. It might be about filtering the data. It might be about detecting changes and working it in an incremental way so that you don't necessarily have to process the entire input file every time you run PropelZ. All of that's encapsulated in the middle part of PropelZ. And then, just like there's an input stage that deals with ingesting data, there's also an output stage that deals with where do you want the results of this to be stored. And again, just like the input stage, the output stage is very open. Certainly the most common thing we do is connect to JDBC data sources. So the output would be a database of some sort. Might be Oracle, it might be Snowflake, might be anything with a JDBC driver is fair game there. So and of course, being open, we supply 5 out of the box that I'll call certified. So you could expect to install one of those, and they would run pretty much unchanged. You still might want to tailor it or change some of the assumptions we make, but they'll work unchanged. And those 5, by the way, are MySQL, Microsoft SQL Server, Postgres, Snowflake, and Oracle. So, but really, as I said, the sky is the limit. If you can supply a JDBC driver for it and tell us a little bit about the SQL syntax that the target expects, we can pretty much connect to anything you might have out there. And again, we're happy to do that work for you. You're welcome to do it yourself. It's really a pretty simple task. There's no coding required. I want to be clear on that. It's just configuration data, settings that control how the output stage works. And by the way, it's not just JDBC data sources. One of the examples that we talk about is we'll take management data, in this case from a mainframe, system messages and console traffic and alerts and those kind of things, and we'll push them into the Splunk product. In that case, there's a custom input stage that knows how to read that management data. And on the output side, instead of talking to a JDBC target, what we do is we directly invoke the Splunk APIs. So again, the sky's the limit. You can have the output really being anywhere you want it to be. And that could be, as I said, it's common for that to be a JDBC data source, but it doesn't have to be. We can certainly take the data, transform it into, let's say a JSON object format or an XML format or a CSV format. And then those output records could be piped to, whatever target you want, whether that's an API model or a file model, or really, again, the sky's the limit there. In the middle part, one of the other very important features that we provide is data transformation. So, in a lot of cases, to kind of go back to that mainframe example where you might be reading a really complicated mainframe file. And, certainly this is not just a mainframe thing. You might have, let's say a binary file on, I don't know, that comes out of some Windows application, and you need to understand it. It's probably not all text. It's probably a mix of different fields. Some are text, some are maybe binary or floating point or all sorts of other formats. So with PropelZ, you can give us a little bit of metadata that describes what those records look like. And then we use that to kind of parse through the records and restructure them in the way that's going to make sense on the target. So if I'm going to a database target over JDBC, what you're going to see in the target, instead of just blobs of data, you'll see rows and columns, and the columns match all the individual fields that might exist in your input record, even though it might be some sort of really, really complicated input file of some sort. So that data transformation is a really key part of what we do. And all of the parts that I'm talking about, I mean, originally Propel started out purely as a ZOS solution. And one of the recent developments we've had is, we've brought the whole architecture that I'm describing to other platforms. So, if you want to run Propels on a Linux server, Windows environment, really anywhere that you have a compatible Java virtual machine, you can generally run Propels there. So the list of platforms that we support is really long, and as I've described, you can reach out and process data just about anywhere. You can run Propels just about anywhere, and the target can be just about anywhere. So very, very flexible that way, very easy to integrate into existing workflows or batch processes of different types that you have, or even for technical user to sit down, just type in a few command lines and get the data that he wants in the format he wants on the target he wants. So anyway, Dusty, what did I neglect to mention?
No, I think that's a great overview. I guess one of the questions I always want to hear from you is, for those that are familiar with our mainframe offering and capabilities, what's a little different from running PropelZ on Windows versus on, natively in the mainframe?
Yeah, and that's a great point. For the most part, certainly at a conceptual level, they're identical. PropelZ is PropelZ, and it behaves largely the same way everywhere. But there are a few platform-specific differences. For instance, I mentioned mainframe and ZOS. I mean, you don't have things like vSAM on other platforms. So, PropelZ has a lot of support for vSAM specific features. I can do a PropelZ operation where I say, I'm going to process a keyed vSAM file, and I don't want to do every record. I just want certain records with keys matching a pattern. Obviously, you can't do that on a platform that doesn't have vSAM and the concept of keyed records and so forth. So that kind of thing is the biggest difference. On Windows, Linux, all of that, binary files tend to be structured a little bit differently. On the mainframe, files are structured into records typically. So when you open and access a file, you're reading it record by record, and the operating system knows where the boundaries between all of those records are. On other platforms, that's generally not the case. On other platforms, a binary file is just a stream of bytes. So you'll see on the Windows and Linux products, there are parameters that you can tell us how do you distinguish where one record ends and the next record starts. That could be done by length, if they're fixed length, just kind of back to back in almost like an array structure. You can tell us each of those records is 4,000 bytes long, or whatever it happens to be. Sometimes you don't have that, though. Sometimes you have variable length records where the length is actually in the data somewhere. So maybe the first few bytes of the record has the length of the record. You can certainly tell us that kind of thing as well. And sometimes records aren't defined by their length, they're defined by delimiters. So like a text file might have a new line every record, and the way you tell where one record begins and the next one ends and so forth is around where the line ends are. So again, PropelZ includes those kind of options to make it a little easier to deal with binary files on other platforms. It's also kind of the mix of encoding and code pages and all of that tends to be a little differently, done a little differently. You know, sometimes what you got is you want to run PropelZ, you know, let's say on a Linux or Windows system, but the input you've got is maybe a file that came from a mainframe. Now, in that case, the text data in these files is probably EBCDIC of some sort, but the text data we store on the local platform, all of that configuration information is probably not EBCDIC. It's probably whatever is, you know, native on that platform. So, you know, we give you those kind of options too. I mean, certainly they're available on ZOS as well, or on the mainframe systems as well. You know, but it's much more common on, you know, other platforms that you're going to want to tell us. So when I reference a file, you know, consider the default for its text fields to be, you know, EBCDIC or, you know, whatever code page you want. That's much more important once you get away from the mainframe. So it's really just those kinds of things that are different. The features, the way you specify inputs and outputs, and the way you connect to different targets. I mean, all of that is identical, and you know, it really behaves the same exact way no matter what platform you're on. So yeah, if you know PropelZ in one platform, you're probably more than capable of running it anywhere else that we offer.
Okay, great. Thanks, Vince. I just want to, there's a lot of use cases for PropelZ, regardless of the platform. So we have many webinars that dive much deeper into these use cases, but I just wanted to kind of share these with everyone. You know, Vince, I think most of these can be supported regardless of the platform you're running on, you know, whether that's COS natively or you're running on Linux or you're running on Windows. Most of these can be accomplished based on, you know, the three-part architecture that we have, and really still in that no-code fashion. Let's talk a little bit about pricing. So the pricing is changing and it may already be updated on the website, but you do have a limited window here to get PropelZ for $50,000 per year by the end of the year. And that's per OS. So if you want it for Windows, it's $50,000, no data limits, no installation limits. It's just by platform. So we make sure we support that OS. For instance, if you wanted it for ZOS and Windows, then it would be two $50,000 copies. And that comes with those drivers that Vince mentioned that are, you know, highly performant, configured, and packaged with the solution. You know, Vince also mentioned some of the input capabilities. So we have an output. So we have a Splunk connector that's $25,000 per year. So if you want to feed Splunk through the Splunk API and basically a pipe or you know, a streaming pipe of data. This is particularly interesting in the ZOS context, but also has you know, broader applications to that as well. But we can get that data into Splunk. There is a demo of that where we show mainframe console messages going into Splunk in that stream. And Vince did mention also the you know, the database input piece as well. And so if you have interest in that connector, please reach out to us and we can help you with that. Or you can just use your, you know, your SQL protocols for that. Just a reminder, we have four products. They accomplish many different use cases, just about any use case you can think of for data integration, particularly in the most challenging cases from mainframe to other platforms. And again, there's webinars, demos for each of these products that are out there, blogs, lots of resources, on-demand customer briefing center as well for all of these. So if you have interest in checking any of those out, take a look at those resources, which, like I mentioned, blogs, demos on demand. Our podcast has all of these as well. Some really great guests from the past as well. And that is all can be found at virtualzcomputing.com. And if you'd like to reach out to us, you can just email us at hello@virtualzcomputing.com, and we'll be glad to get back to you, or you can submit a form on our website, and you can and we'll get back to you promptly on that. All right. Thanks for joining us today, Vince. This was kind of a quick hitter to end up the year. We wish everyone happy holidays and happy new year. We'll catch you then. Please watch out for a couple webinars coming up that are actually being hosted by Google and AWS featuring VirtualZ products. And so there's some really cool demos and use cases that'll be available for those. So check out our events page and you can register directly for those. And we'd love to have you join those partners and us for those. All right, Vince, Happy New Year. Take care.